All right, looks like we have people joining. We'll let everybody enter the conference hall here. And we'll only wait just a couple of seconds while that happens. In the meantime, let me get started. So hello, everyone. I hope you're joining us safe, healthy, and happy from the comfort and security of your own home. Since so many of us are working from our homes, go ahead and tweet a picture of your work from home setup and include the hashtag VDI Summit in your tweet. Since so many of us can get creative about our work from home situations, we'd love to be able to share those and take a look, see how you got it going there. If you have questions after the session today, I'd encourage you to either reach out to Rody directly or you can submit them here and we'll make sure that Rody gets them and responds to you. And Rody has also agreed to share his slides after the session today. And we will make this session available via video for the next 30 days if you need to see a replay. Stick around for a raffle after the event. Thank you to all of our sponsors. And now I'd like to introduce our speaker today who has spent a great deal of time improving the user experience for folks like us working from remote locations like our homes. This session could not have come at a better time when many of us are struggling to improve the user experience for those of us that are working from home after being displaced from our standard on-prem machines. Joining us from his home in the Netherlands, I'd like to introduce Citrix CTP and NVIDIA NGCA, Mr. Rody Kossen. Take it away, Rody.
All right, thank you. Thank you. So today we're going to talk about remoting protocols. I'm already introduced. You can reach out to me on Twitter. You can find my website or connect with me on LinkedIn. So what to expect today? Well, as you see my webcam, it's all about user experience today. So what to expect? We're going to start with some basics, just to get to know all the different terms of remoting protocols. What are the different encoders? How to test? What some real life scenarios and some lessons learned from those scenarios. So I want to start with a few key takeaways already, because I think those are very important. So user experience is key. Invest time to enhance it. And you need basic knowledge of protocols to make the right decisions. And next, testing your environment with your applications and your network heuristics, because that's also very important. All right, let's start with some basics. Some of you may have seen some other webinars or other presentations. So maybe this is something you have already seen, but it's always good to get some knowledge. So there are so many terms these days about encoders, protocols, and so on, like YUV 420, VP9, H.264, color Gamut, but what do they really mean? So let's first start with some colors, because colors seems to be very simple, right? We can see colors, or most of us can see colors, but the cool thing is that colors are a perception, so they're very relative. The green that I see is probably not the green that you will see. So we never really perceive what color really is, as it physically is. This fact makes the color the most relative medium in art. It's a cool quote I found somewhere on the internet. And the relative part is also that we don't see all the colors that are visible, because we can only see 10 million colors, because the way our eyes are built. But some insects or birds like pigeons were quite stupid, but they can see 10 billion colors. So they can also see UV light, for example. So their world looks really different than ours. But as I said, color is a perception. So if you look at this picture, do you think that the A and B, the gray around it, are the same color? In this picture, I would say no. But what if we connect those two? Suddenly, it's the same color. This is just a perception. So it's the way our brain is connected, and the brain is wired. If you still don't believe me, take a screenshot, take a color picker, and they are both the same color. Cool, huh? And what about this one? Do you think that the middle bar is a gradient? So the outside is a gradient from dark to light, and somehow the middle is reversed. But what if I remove the gradient? The bar isn't a gradient, it's just plain gray. This is also a trick that our mind does. I just added white borders around it, and you suddenly can see that it's completely gray. Again, take a screenshot, check it with a color picker. So our brain does cool things with color, but in a digital world, things are a bit different. So let's start about that, because it's really important to know the basics of colors in a digital world to know how encoders or codecs work. So let's start with bit depth. I think you have seen this quite often, maybe in videos, maybe already in encoders from Citrix or other vendors. But the bit depth can be used in two different ways. It can be used to describe the number of bits used to indicate the color of a single pixel. So for example, 24-bit, that's a very common bit depth. But it can also be used in a different way to describe the color component of a single pixel for each color component. So for example, if you have an RGB, red, green, and blue description of a pixel, then it can be 8-bit for red, 8-bit for green, 8-bit for blue. It can also be combined with alpha, which means that describes the transparency of a pixel. So a few commonly used terms are high color, which is 16-bit or 32,000 colors. It's a bit old, not very common these days. Or it can be true color, 24-bit, which is around 60 million colors, which is more than we can perceive with our eyes. A new one you would see, I think in Blu-rays, is 30-bit or 10-bit per color, which is 1 billion colors. And you would say, why do we need this, as we can only see 10 million colors? Well, it's also because we see colors in a real world very fluently. So there's in the left picture, you can see 10-bit colors. And in the right side, you can see 8-bit. You can really see that there's a gradient from orange to blue. You can really see lines with different colors, because the colors between soft yellow and a bit harder yellow, there are not many colors between it in 8-bit, but they are with 10-bit because there are 1 billion colors available. Another term you will see mostly in Blu-rays or on monitors is color gamut. And this describes a subset of colors which can be displayed in relation to the human eye. So at the right side of the screen, you can see the color gamut. The outside box is what we can see with our eyes, so the 10 million colors. And the two triangles you can see are the two standards, which are quite common on Blu-rays or DVDs or TV broadcast. So REC 709 or REC 2020 are very common standards. Others we see are Adobe RGB or Super RGB. But you can see that most monitors can't even display all the colors we can perceive with our eyes, because even the black newer standard is not nearly the amount of colors we can see. All right, so these were a bit of basics about colors. Let's talk about compression. And why do we need compression? Because every encoder uses compression in some sort to take a screen or a moving image from A to B. So why do we need why do we need it? if we look at a single frame, full HD, so 1920, 1080p with 24-bit color is already almost 6 megabyte per single frame. So with 30 frames per second uncompressed, it's already 177 MB per second. Megabyte, not megabit. So I have a 500 megabit connection at home. I can't stream this. And if we go to 4K, it's even more ridiculous. At 60 frames per second, it's almost 1.5 gigabyte per second. So that's why we need compression. And there are different types of compression. Lossy, which is irreversible. It uses a mechanism which reduces data size, but you can't roll it back. So you always lose data. So some examples, MP3 for music, JPEG compression. And you can see an example at the right side of the screen. So the left picture of the bird is a bit less compressed, where you can see that the right side has a heavier compression and information is lost. As we can see, it's more blurry. But there are also lossless compressions, and that's reversible, but that's also a good thing. But because it's used in zip, for example, to compress files, it would be really annoying if you extract a zip file and you lose half of your data. Another example is PNG, which is also quite common in remoting protocols. And another term which Citrix invented, I think, is visually lossless. It's irreversible, but the difference can't be seen by the human eye. The compression is also done mostly by a video codec these days. Why? Because they can do magic with it. So I took a screenshot for a comparison of my homepage, tweakers.net, a technical website from Netherlands. So PNG, which is uncompressed or lossless, as we saw before in the previous slide, it's almost 900 kilobytes. And I also took a video of 5 seconds with 30 frames per second of the same web page. It's only 400 kilobytes in size. So it's 180 frames in 400 kilobytes. Strange, right? But compression comes at a cost. We will talk more about that later. Because compression is also done by something called chroma subsampling. It reduces the amount of color information from an image. And it's based on the idea that our visual system is less sensitive for color than luminance. And it allows picture clarity to be maintained. It uses a standard, also known as YUV, and it can reduce the file size up to 50%. So how does this work? So here you can see the Y, the U, and the V. So the luma and the chroma. The chroma is the color, the luma is the luminance, so the brightness. And if we take 8 pixels, so 2 rows of 4 pixels, with chroma subsampling 444, it means that all the information is used and all the pixels remain with their original color information. But a very common used chroma subsampling rate is 420. It's used on YouTube, most video broadcasts, even Blu-rays. But it means that you only take, of the 8 color pixels, 2 pixels, because the first 4 are the luma, so we take all the luma information. The 2 means that we only take 2 pixels of the first row, and the 0 means that the second row isn't used. So you can see on the screen that in the right bottom, that only 2 pixels got their color. And it's completely different from the top left, 444. But the funny part is, in moving images, we can't tell the difference. But there is a downside. Because in still images or images with a heavy contrast, like text with blue text on a red background, the text becomes fuzzy because colors seem to blend into each other. So on the left side, I hope this is visible for you guys. Otherwise, I would recommend to Google on YOV 420 versus 444. On the left side, you can see that the image is a bit blurry. And on the right side with 444, it's crystal sharp. This is also visible when you do 2D AutoCAD, for example, and you have lines with a high contrast. So green on gray or red or on blue, something like that. On the left side, 420, on the right side, 444. On the left side, I can see that the green is not that bright, not that, green, it's more gray. And also the lines tend to be less sharp. All right, so these were the basics I want to tell you today. There is so much more to tell. I recently wrote a blog about it. So if you want to know more about all these basics, take a look at it. So let's start with the different encoders then. So today Citrix has previously, 2 weeks ago, I think, released the 2003 or this 2003 release of their virtual apps and desktops. And there are many different encoders. They have 4 encoders today, or 3, if you don't count lossless compression as an encoder, but they have ThinWire, which uses JPEG or PNG, or a combination of that. They have adaptive display for active changing regions. They have adaptive display with build to lossless, which I will tell more about later on. I will show you some examples. And they even enhanced it in the latest releases with an option to check what's on the screen and recognize if they have to do lossless or have to do YOV 420, because build to lossless is a combination of that. And they have the option to do H.264 with YOV 420 or 444, or the option to do H.265, which is a optimization of H.264, but it comes at a cost of having the need of more compute power. So for H.265, you need to have a GPU in your VM. And the last option is lossless compression. So if we compare that with VMware, you can see that they do the same. They use JPEG or PNG. They have a switching encoder instead of the 4 active changing regions. The difference is that Citrix can do the switching in parts of the screen, and VMware does it for the whole screen. So they do either JPEG, PNG, or H.264. And they don't support NVENC for the H.264 encoding. And they also use H.264 or H.265 for video encoding. The last one I have as a comparison is Nutanix Xi Frame. I don't know if Ruben is still on, but Nutanix make heavily use of video encoders. So they use H.264, YOV 420, or you can do 444 if you enable the HQ option, but that's only available on Chrome. So you can see that most of the encoders today use the same technology, but they can use it differently in the encoder, and there are differences between them. So it's good to test. So how do we test, or how do I test? How do I test for my customers? How do I enhance the user experience with testing? There are different test procedures available. So you can either run benchmarks like 3D Mark or PassMark, where you can do heavily 3D benchmarks to check if your platform performs well. You can use testing tools like Login VSI or Rex Analytics. And those are more repeatable and also scalable. So you can also introduce noisy neighbors. So what happens if not only one user tests your platform or is running on your platform, but what if there are 60 users on a single server, for example? And another thing you can do with your end users is a Pepsi Coca-Cola test, right? So a blind test and give them 2 options without telling the differences and ask them a few questions and let them answer these questions by giving a number between 1 and 5, where 1 is bad and 5 is great. So you can ask them how fluent was the desktop, how good was the image quality. This is also a way to get to know how the user perceives the user experience. And for testing, it's also very useful to have a good tool. So I'm part of the RDAnalyzer team. I'm a co-developer. And RDAnalyzer is a tool where you can monitor the remoting protocol, but you can also directly change settings on demand. So that's currently only supported for Citrix and VMware. So on the right side of the screen, you can see a screenshot of a Citrix endpoint where I can live on demand can change, for example, the visual quality from high to always lossless to see the difference. And also to measure the differences in terms of how many frames per second I have or what's my network, my round trip latency. It only costs 50 euros a year for a 1-person license, and we also have a company license, so you can use it throughout your whole company. I use it very often when I'm at customers optimizing their user experience. But don't forget to test with your applications, because applications matter. And your network behavior, like bandwidth, latency, or packet loss, because those are very important in terms of user experience. And don't forget to test on your endpoints, because also endpoints can make a difference. All right, I hope you're still awake so far. Let's get in some real life scenarios. Some scenarios I've seen in the field and have tested quite often. So the first scenario is a CAD worker, so a high-end CAD worker, which uses AutoCAD, MicroStation, DraftSight, or other 3D modeling. And they need a high-performance VM, like they start with 2 vCPU for the more simple modeling, or 4 or even more vCPU. And in these scenarios, you would always see a vGPU to support the CAD application. So I think the most common are T4 2Q profile or T4 4Q profile, depending on the resolution on the endpoint. And with Citrix virtual apps and desktops, I would recommend, or I would see the usage of NVEnc, so hardware encoding on the VM to encode the H.264 compression. That will drop the CPU usage for the encoding part. And for AutoCAD or 2D CAD, we would see YOV 444 quite often, as I explained earlier. So how does that look if we run a demo? What's the user experience? So I've captured this demo with RDAnalyzer using a frame grabber in my lab to directly grab the frame from the endpoint without interfering with it. So in this test, and you will see that this test more often further on, I will use a Lego 3D model to show you the differences. So here you can see that with YOV 444 and 30 frames per second, we can hit those 30 frames per second quite easily. It's really smooth, the image quality is great, the colors are great. So, all right, happy user, right? But if you look at how much bandwidth we use, keep in mind that it can take up to 80 megabits per second to transfer this image to the end user. So for this setting, I use the Encoder Settings for the entire screen with the image quality set to always lossless. I use the hardware encoding, and to be able to do YOV 444 with hardware encoding, you need to enable allow visually lossless. As I explained earlier, this is a term Citrix invented, but you need to enable it. If you don't enable it, the hardware encoding will not be used and it will be done on CPU. But there's a downside. It only works with Windows endpoints, but if you have them, users will be quite happy. As you saw, the image is great. It's very smooth. But then COVID-19 or Corona happened and everybody started working from home. So what if we do the same, but now with a 4 megabyte connection, like ADSL? Is this still valid? How do you optimize the user experience, or how does this impact the user experience? So first start with the first question. Do you need the Citrix Workspace app, or can you use your browser? Because there is a HTML5 client. So I'm working from home, I have my own laptop, but I don't want to install the Workspace app, or I'm unable. What's the user experience? So in this test, I compared 3 different endpoints. So on the left bottom, you can see a Windows 10 Surface laptop with a Citrix Workspace app. And you can see also the Chromium browser on the left upper corner and Firefox in the upper right corner. This is with full bandwidth, so no 4 Mbit yet. That will be shown later on. So let's see what the difference is. So here you can see the different settings. So it's set everywhere to always lossless with YUV 444. So let's compare them. Right, so the model is loading. All right, it's okay-ish, but you can clearly see that the bottom left one is more smooth than the HTML5 clients. So it really matters to have the Workspace app installed. So this HTML5 is a great fallback, but if you have high graphic intensive applications, it's better to use the native client. But wait, they said any device, right? So most vendors say you can run it on any device, no problem. Okay, it works on any device, but how's the user experience? So here's a comparison between Windows 10, Mac OS, the newest IGL UD3 with Ryzen, and a Intel NUC running on Ubuntu. And as I mentioned before, the YUV 444 works only on Windows. So what you can see here is that the fallback of YUV 444 with Citrix on the video codec is thin wire, always lossless. You will get the same image quality, but you will see that the user experience is very different between those endpoints. So in the upper left corner, you can clearly see that it's more fluent. You will easily get 30 frames per second, but the encoder on the other endpoints is using the CPU and JPEG compression or PNG compression to encode the frames. You can clearly see that it's struggling to keep up, and it's not the endpoint hardware, but it's the encoder that's not capable of getting all those frames per second through the wire. And what if I have a 4 megabit connection? So in this setup, I have the same YUV 444, but only then with a 4 megabit connection. So you can see here that Citrix sees that I have 3 megabit available. And the user experience is quite different. As you can see, it's only a few frames per second. It's really struggling to get those frames through the wire. It's only 2 frames per second. So the policies you use internally are not the right ones to use externally if people are working from home. So how do I optimize the user experience in this scenario? So there's another option that Citrix introduced, and that's build to lossless. So what it does, it's using PNG compression for the lossless part. So the image quality is really high. But for when an image is moving, they will use H.264 YUV 420, which is better for compression and moving images. So let's do a comparison between the two. So on the left side, you can see I have a 3 megabyte connection with YUV 444. And on the other hand, I have the built to lossless. And in the bottom graphs, you can see the CPU usage, the GPU usage, and the encoder usage. So while the model is loading, you can also see how built to lossless works, because you can see it's building up the image. It's not that sharp at the beginning, but it sharpens when the image is still. So when it will start moving, you can see that it will switch back to 420. It's not that sharp, but it's very great user experience. It's moving pretty quickly. And you can also see that the encoder is used much more on the I think those things are flipped, but you can see the green part, it's flipped here, sorry for that. But the encoder is used much more on the built to lossless part because we get more frames through the wire. So the optimal setting for these users would be to use the encoder for active changing regions with the image quality set to built to lossless and hardware encoding enabled. And it's also very important to enable EDT, or Enlightened Data Transfer Protocol, which uses UDP. And also a thing to note is that built to lossless is supported on all endpoints, but it's always good to test it on your own endpoints, because an endpoint can have an old Citrix receiver or workspace app, which is not working great with the newest encoding features. So always test with your own endpoints. So let's switch to the next scenario. We have an office worker who's working also from home or working from the office. And they use Microsoft Office or other Office applications. And they sometimes use YouTube or other instruction videos or moving images. So it's a combination between text and videos. They need medium performance, so I would size it around 2 vCPU, 6 GB of RAM with a Windows 10 VDI machine. And I would add a vGPU just for supporting the graphics, the videos, with a T4 1B profile or a T4 2B profile, depending on the endpoint resolution. So this is a very common scenario, right? So for moving images, what's the difference if we use JPEG encoding thin wire or H.264 YUV 420? What's the difference in user experience? So what if the user opens YouTube and starts a video? So again, I use the same model for these purposes, just of showing how a moving image looks like when you use different encoding types. But you can imagine this is the same for a YouTube video because it's also a moving image. All right, it's loading. There we go. And on the left side, you can see that I can read it. I hope you can read it as well. The CPU is hit by the encoder with 44%. So one core almost full blown for only the encoder. And it's struggling to send over the frames, to encode the frames. And on the right side, you can see it's very smooth. So here you can really see the difference between JPEG encoding and H.264 encoding for moving images. So, all right, let's go with H.264. But what happens if I move to Microsoft Office, which is mostly text? Here you can clearly see that H.264 is struggling because with 420, as explained earlier, it's different compression. It's the line and the colors seem to blend over in each other, and the text is not sharp. And this is quite hard to read. So you can imagine if you have to work a full day in Microsoft Word with the right image quality, on the right side, that image quality, that's quite hard on your eyes. So ThinWire is the better part here. But now we have a struggle, right? Because if the user switches to YouTube to watch a video, ThinWire struggles. So it's a hard choice to make. Do we have to go left or right? So luckily, there's an option for actively changing regions. So active change regions to the rescue. Citrix invented this a few years ago. And the cool thing is it's a combination between H.264 and JPEG encoding. So the green dotted part here is a video. It's recognized by the encoder, and that part is encoded, which can be used, can utilize the GPU as well for encoding it with H.264 or even H.265 for even lower bandwidth usage. And the blue and the red parts are either static images or text, and those are compressed with JPEG or PNG. So the optimal setting would be, for this scenario, for actively changing regions with the image quality set to high. And if you have a GPU, don't forget to enable hardware encoding, which is enabled by default, but still good to check. And it's supported on all endpoints. So these were a few real life scenarios. So what were the lessons that I learned from it? Optimize the encoder settings for your different workloads. As you can see, there are different options for different workloads. CAD, Office, or maybe other workloads you have in your office. And the network conditions have a high impact on user experience. As you were seeing before with 4 megabit in comparison to a normal LAN condition, the user experience is really different. And try to keep up with the release cadence of vendors. So use the current release if you have high demand for user experience. So for example, Citrix came up with EDT, built to lossless enhancements over the past year, various other optimizations, and they even introduced lossy EDT, which I hadn't had the time yet to test, but it's for connections where you have either high latency or packet loss to further optimize the user experience. And they optimized built to lossless with better image recognition, and they can utilize now H.264 for moving images, as you've seen before. So just try, make mistakes and learn from it. So just try it in a lab environment or in your own production environment, try it with a test user, make mistakes, struggle, but learn. And always ask questions if you don't know. The community is always very helpful for that. So back to the few key takeaways. User experience is key, so invest time to enhance it. And learn some basic knowledge of the different protocols, so you can make the right decisions, so you can understand why the image quality is not what you are expecting. and testing your environment with your applications and your network characteristics. So thanks. I think I'm precisely in 40 minutes. If there are any questions, please reach out to me, and I will happily answer them. Thank you.
Fantastic, Rody. That was deeply technical, but very important information. I know you could be a hero pretty quickly by understanding and implementing some of that stuff, especially for end users that are struggling. We don't have any time for questions and answers at this point, but if you've submitted a question, like Samad has, we can make sure Rody gets that and can respond to you. I'm sure he'd be happy to do that. Again, he'll share his slides. And this video content will be made as a replay here very soon, so you can watch it on demand for the next 30 days. So thanks again, Rody, and be sure to check out our next session by Nutanix, which starts in about 5 minutes. Take care, everybody.
Thanks.